All right, let's take a look at today's lesson. What we're going to be looking at today are arithmetic sequences and series. In the last lesson, we looked at just in general sequences and series and what the difference between them is. We described a sequence as a list of terms with a comma between them. A series is when we add up all those terms. Instead of just listing them, we would add them. So that's basically the difference. Today we're going to look at some specific kinds of sequences and series. The first kind is arithmetic. This is a formula that we have. And actually, these formulas will not be given to you on an assessment. You would have to memorize them. A reason being is it's important that you know that formula. We would need that if we were going to create a formula for an arithmetic series, which we certainly could, or sequence. We would need to know that formula. So D stands for the common difference. In other words, for arithmetic, like it would be add 3, add 3, add 3. To get the next term, you would add 3 or whatever. Or you could actually subtract 5, subtract 5, subtract 5. So that would be D, which is the common difference. What are you adding repeatedly or subtracting repeatedly? A happens to be the first term in your sequence. We have two different formulas for a partial sum. Let's say we wanted to add the first 100 terms. So we would use one of these two formulas, again, which you would need to memorize. Let's talk about the pros and cons of each of the formulas. This bottom one, I think, is easy to remember. But in order to use this one, we would need to know how many terms we're adding and what the last term is in order to use that formula, right? So that's what we would need to know, how many terms we're adding and what is the last term. In this particular formula, it would be nice if we knew how many terms that we were adding, but many times we use this one when we don't know what the last term is, or we don't know how many terms we're adding. We might use this one. They both will give you the same answer. It's just what's more convenient for you for the problem that you're working. That's just a decision you have to make, is which one would be more helpful. The second type of sequences that we're looking at are a little different. Let's look at this. So if the first differences of a sequence are all the same, then it's arithmetic. That's the kind that I was just talking about, where they have a common difference. But if the second differences are the same, then we have something that's quadratic. We can represent it by this quadratic. And this is the template of the quadratic that it would look like. So the nth term, our formula to generate all those numbers would look like this. And we're going to investigate both of those types today. We're going to look at both of those. Any questions before we get to the examples? Yes. I'm going to actually show you on the next slide what a second difference is. So, in other words, if I had a list of numbers and I looked at the first differences and they weren't, like, say the first difference was 5 and then 7 and then 9. The first differences are all 2 apart. So the second differences would be the same, would be 2. That's what this means, first and second differences. And we have an example of that. Okay? Anything else before we get to our examples? All right, so let's go to the next slide and let's take a look at the examples for today. All right. So on the first example, we are told that we have an arithmetic sequence. And we're told that, let's see, the 11th term is 52 and the 19th term is 92. So I'm just going to write down what I know. I know A sub 11 is 52, and I know A sub 19 is 92. Now, there's a little formula that we can use to find the common difference, or you can just do it in your head. I mean, it doesn't really matter. I kind of like using this little formula. And so arithmetic sequences are kind of nice in that we have a little formula that we can use to find the common difference. So to find the common difference, what we would do is we would take the two terms that we would have, and we would take the difference between them, we would subtract them. The larger, like the 19th term, so 92 minus 52, And we would need to be in that order. We would take the term that was farther along minus the term that was before it. And then what we would do is we would take the difference of the term numbers, like the term 19, term number 19 minus term number 11. And then we would just, do our arithmetic, and we would get 5. The common difference is 5. So that's an easy little technique for finding the common difference if we have two terms that aren't right next to each other. The other thing, what else do we need? Well, we need to know what the first term is to be able to write our formula. We need the first term. And so you could do this in your head. You could do 92 minus 5 minus 5. I mean, you could, or start here, minus 5 minus 5 minus 5. But why don't we just do, to get the first term, why don't we take the 52nd term and take away 10 of the common differences? Wouldn't that give us our first term? Right, we take the term that we have, we take away 10 because I have the 11th term. I need to get down to the first term. So I need to take 10 terms away with that common difference. So a sub 1 turns out to be 2. Now we have the two important numbers, d and a, so that we can write our term, our general term. So a sub n equals 2 plus n minus 1 times d. Now for me, I'm fine with that. I know in Algebra 2 there was an emphasis placed on distributing combined like terms. And truly, if you're going to be using this a lot, it would be easier to distribute and combine like terms. It would be more efficient to do that. But I'm not going to require that for the actual formula. So you could leave it like this if you wanted to. I would be fine with that. Or you could distribute and combine like terms, which would give us a to the n equals 5n, would that be minus 3. So either of these is acceptable for your formula. So now that we have our formula, let's find the thousandth term. So we need a sub 1000 equals 5 times 1000 minus 3, or 5000 minus 3, which is 4997. So a sub 1000 equals that. So using it, it's kind of convenient to have it written like that if we're going to use it. But again, it's your choice what you want to do. Certainly the final one needs to be simplified. I need to know what the number is. I mean, leaving it like this would be not acceptable. Right? I need you to actually find me the number. Okay, so how are we on that first one? We okay? All right, let's look at this one. We're supposed to find a formula. So what I like to do is investigate the numbers. What's going on with the numbers? The first thing that I would do is look to see what the difference is between them. So the difference between these is, 8? The difference between these is 10. The difference between those is 12. The difference between those is 14 and 16. So the first differences are not the same. But if you look at that, if we did the second differences, that would be the same, right? So if I took the difference between these two, I would get a 2. And the difference between these two, I would get a 2, 2, and 2. So here's where my second differences are the same. What that means is this is going to be quadratic. We're going to use that quadratic type, which is a sub n equals, we have a n squared plus b n plus c. Okay, so what do we do? Well, what we're going to do is we're going to take, and I like using term number 1, 2, and 3. Do you have to use term number 1, 2, and 3? No, not at all. You can use any 3 terms you want. But to be perfectly honest, you know me, I don't like really big numbers. I would rather use small numbers. So I'm going to use term 1, 2, and 3. Term 1 is 12, and I'm going to plug that term into here. So I have 12 equals a, and my term number is 1 squared, plus b times 1 plus c. Okay, so rewriting that so it's easier to look at, that would be a plus b plus c equals 12. And if I use the first term every time, this is always going to be the same, a plus b plus c. equals the first term. It's always going to be the same, right? Because the first term has a net term number of 1. Now I'm going to use the second term. So I have 20 equals a times 2 squared plus b times 2 plus c. So rewriting that in a more usable fashion, I would have 4a plus 2b plus c equals 20. And again, if I use the second term every time, this part of it is going to be the same, right? Because the term number is 2. 2 squared is always going to be 4. 2, that's going to be the same. This is the number that would change. Okay, now let's get our third one. Let's use the third number, which is 30, which is our third term. A times 3 squared plus b times 3 plus c. Again, writing that in a more usable form, that would be 9a plus 3b plus c is 30. And again, if I always use the third term, it's always going to look like this, right? Because it's a third term. This would just be different. So now we have a system of 3 equations and 3 unknowns. We're going to solve that system. I solve by elimination. You can solve however you want to. What I typically will do is I will subtract these two, and I'm actually not going to rewrite it. I'm going to do the subtraction in my head. You can rewrite it if you want to. I always like mine to come out positive, so I would do 4a minus a gives me 3a. 2b minus b gives me b. C minus c is nothing, goes away. And 20 minus 12 is 8. Again, it's a pattern. If you use the first and second term to do this, this part is always going to be the same, right? It's always going to be the same if you do the same technique. Now I'm going to subtract these two. So 9a minus 4a is 5a. 3b minus 2b is b. And 30 minus 20 is 10. So if you use this technique, this first part should be the same. Just the numbers are going to be different. Now, I'm going to subtract, and I'm going to get negative 2a. The b's go away. 8 minus 10 is negative 2, so a is 1. So once I have one of the numbers, I'm going to back substitute. A is 1, so I'm going to go backwards. I'm going to actually go into this equation right here. So 3 times 1 plus b equals 8. So b is going to be 5. Right, and then I'm going to continue to back substitute. I'm actually going to go all the way back to here, to this a plus b plus c is 12. I just kind of like that one. We know you can go to any one of them, but I'm going to go to that one. So 1 plus 5 plus c is 12. C 1 and 5 is 6, so C is 6. So now I have all the information that I need to write my nth term. It's going to be in this format right here. So a sub n is going to be, let's see, my a was 1, so n squared. B is 5, so plus 5n, and C was 6 plus 6. And that gives me my formula for this sequence. Okay, how are we? So that's how we would generate the formula for our sequences that have a second difference that's the same. Okay, this is not arithmetic, but I put it's in here because the second differences are the same. You know, instead of the first differences being the same, the second differences are the same. So this is not arithmetic, it's quadratic, but still, it's got a good spot. All right, questions on number 2? Okay, I need to actually erase some of this to have more room for number 3. Does anyone need this? We good? Okay, let me erase some of that. So do our last problem. All right, so the last one. How many terms of the arithmetic sequence 579 must be added to get 572? Now this is one where we don't know the term, how many terms. We have no idea, and we actually don't know the last term number. So the more convenient summation formula to use would be that on that page, the first one, that S of n equals n over 2. That one would be the most convenient one to use. That's the one I'm going to use. So I know my sum is 572. And then my formula is n over 2 times 2 times a. Well, I know what a is, right? I know my first term. It's right here. So that's 5. And then it says plus n minus 1. I don't know what n is, but I do know what the common difference is, right? The common difference is a positive 2. And now that becomes the equation that I need to solve. I just need to solve that for n because it wants to know how many terms do I need to add. Now let me be a little bit specific about our formulas just so we are clear. So when we're taking a quiz or a test, we're going to have a calculator, but you're not going to get credit for just an answer. Well, you could do that in your calculator. I need to see the formulas. I need to see what it is that you're doing. I'm fine if you use a calculator to, help with this number crunching stuff, but I'm not fine if you just use a calculator to find your answer. Does that make sense? Because that really doesn't show any knowledge. It just shows you know how to use a calculator. So I just need to see the formulas. In order for you to get credit, I need to see the formulas. So let's continue working on this one. So I have 572 equals n over 2 times, let's see, that's 10 plus 2n minus 2. Combining like terms, I get 8 plus 2n. n minus 2 equals 572. Of course, we know there's a lot of different ways to solve equations. You may have a different way, which is fine. I'm just showing you how I would solve it. Since these numbers turn out very nice, I would just distribute this here. Otherwise, I might multiply both sides by 2. I mean, just depending on but this turns out nice. So 8n over 2 is 4n, and n over 2 times 2n is n squared. So this is a quadratic, so this would be n squared plus 4n minus 572 equals 0. And we look at that, we're like, oh my gosh, what in the world? But let me give you some comfort, right? N is an integer. It has to be an integer, and it actually has to be positive or 0. Right? So it's going to be factorable. As weird as they look, and they may look very weird, they're going to be factorable. Okay? So you're thinking, oh my goodness, 572? What are we going to do there? It is factorable. You would typically have a calculator to help you with the number crunching. I don't expect you to multiply all the things together to get 572 in your head. So this actually turns out to be, the factors are 26 and 22. It's n plus 26 and n minus 22 are the factors for that guess and check. So that means when according to this quadratic, n could be negative 26 or n could be 22. Now, hopefully we know that n is not allowed to be negative, right? These are term numbers. We don't have any negative term numbers. So this is not possible. We can't have an n number that's negative. So our only option is this one. So the number of terms to get 572 from that sequence, we need 22 terms to get to 572 from that sequence. Okay? Questions about that? All right.